So you got like nickel-based cells, and you got iron-based cells. The nickel-based cells have more energy density.
Tesla just changed the rules on everyday charging. New nickel-based cells let you set 90% as your daily limit, cut long-term fade, and keep the performance punch without babying the pack. No gimmicks, just a real upgrade you feel on weekday mornings and long weekends alike. Here is what changed inside the cathode and why your next charge routine gets simpler. The reveal that slipped past the noise. The message arrived without a keynote or a countdown because Tesla's vice president of vehicle engineering said during a segment on a mainstream car show that the company's next-generation nickel-based battery technology is sufficiently durable that Tesla plans to recommend a daily charge limit of 90% for vehicles equipped with these cells, which immediately reframes ownership habits in markets where nickel chemistries dominate and effectively gives drivers more usable energy every day without changing pack size, hardware footprint, or the rhythm of their lives. And it matters that this was not rumor but words from the executive responsible for the vehicles themselves. This guidance is especially relevant in the United States, where most Teslas ship with nickel chemistries rather than lithium iron phosphate, because a higher everyday limit translates into an immediate increase in practical range for commuting, spontaneous errands, and late afternoon plan changes that used to force a stop. And while the difference between 80 and 90% sounds modest on paper, in the rhythms of real life, that extra 10% often determines whether you head straight home or take the scenic route without thinking twice. So, if tomorrow morning your app slider quietly moves from the old habit to the new recommendation, how quickly would your routine adapt to the extra cushion you did not even know you were missing? Why 90% changes? The conversation. For years, nickel-based packs were treated like athletes who needed a careful training plan, since they offered the energy density and power that make long-range and performance trims feel effortless, yet asked owners to be more conservative in daily charging to limit calendar aging, while lithium iron phosphate enjoyed a reputation for cost, stability, and tolerance of full state of charge at the expense of packing fewer watt-hours into the same volume, which meant that buyers often chose between simplicity and stamina, and service advisors repeated the same guidance that became folklore in owner forums. When the company responsible for so many nickel-based cars says the next iteration can comfortably live at 90% day after day, that convenience gap narrows in a way owners can feel on a weekday morning rather than in a spec sheet, because you do not need to schedule a road trip to benefit, and you do not need to relearn your car. You simply start the day with more energy available and less anxiety about long-term pack health, and that is precisely the sort of incremental advantage that compounds over years and miles. If the sprinter suddenly behaves like a marathoner in daily life while keeping its top speed, does the old either-or choice still make sense? The chemistry hidden inside the headline. The quiet hero behind this shift is the cathode, because Tesla filed and publicized work on doped cathode active materials and the methods to make them. And doping in this context means intentionally introducing tiny amounts of other elements into the crystal structure, so the material resists the mechanisms that normally erode capacity over thousands of cycles, which is not marketing flourish, but classic materials engineering that hardens the most fragile links in the chain, so voltage, temperature, and repeated intercalation do not carve away performance as quickly as before. Summaries of the company's technical documents describe a meaningful improvement in retention, with older cathodes holding a smaller share of initial capacity under long-life conditions, while doped versions hold substantially more, and commentary on the same approach notes that a particular multi-element recipe kept degradation surprisingly low over the same period, in which a non-doped reference cell lost far more capacity, which is exactly the sort of result that would justify changing daily state of charge guidance from 80 to 90%, without treating owners as unpaid beta testers. If the lattice itself keeps its shape deeper into life, how long before your battery outlasts the rest of the car's moving parts? from studio conversation to owner habits. It matters that this update did not arrive as a rumor or a third-hand leak, because the message was delivered plainly and then echoed by communities that follow engineering closely, with the emphasis remaining the same, namely that the new nickel-based chemistry is durable enough to support 90% on a daily basis, and that the convenience gap with lithium iron phosphate is now half what it used to be, which lands less like a boast and more like a steady recalibration of how owners should treat their packs the moment these cells enter production cars. For drivers, the difference appears in small mercies that add up, because commuters can skip a midweek top-up, fleets can shave a stop from a shift, and families can accept an unexpected detour without the mental math that used to accompany any day that drifted beyond routine. And the beauty of this kind of improvement is that it hides in plain sight, since no one needs a new charging ritual or a deep dive into battery science to enjoy it. If convenience is the currency that wins mainstream adopters, is this the quiet change that moves the needle more than a new badge ever could? Nickel and LFP. After the upgrade, none of this means lithium iron phosphate loses its place, because LFP still wins on cost, stability, and stress-free full charge tolerance, and remains a natural fit for standard range trims and many fleet applications. Yet the historical complaint that nickel packs felt fussy in everyday use loses force if the owner guidance climbs to 90%, while the pack retains more of its capacity deeper into life, which means buyers can select a chemistry based on energy density, packaging, and performance needs without feeling pressured by maintenance anxiety or different rules for the same school run. That balance is exactly what long-term adoption requires, because mainstream drivers do not want to memorize battery etiquette. They want a car that behaves consistently, and if nickel now carries the legs of a grand tourer and the manners of a daily commuter, then showroom conversations change from warnings about upper limits to simple discussions about how far you travel and how you like your power delivered, which is the kind of clarity that makes choices easier rather than harder. When both chemistries feel simple and one gives you more miles per kilogram, which knob do you turn first? Cost, weight, or headroom? What the patent hints about direction. The doped cathode work sits alongside a broader thread of innovations that focus on strengthening active materials and simplifying high-volume manufacturing, because the company has pursued recipes and processes that reduce capacity fade in manganese-rich and nickel-rich systems, and has paired that chemistry focus with production approaches that cut solvents, speed lines, and lower cost. And while those factory innovations are their own story, they support the same end state by making it viable to bring better materials to scale rather than leaving them on a lab bench. This is why the 90% guidance matters beyond owner convenience, because pack longevity determines second life economics for stationary storage, shapes warranty calculus, and helps fleets calculate residual values with more confidence. And as the curve flattens on capacity loss, the window for repurposing packs widens, so the same hardware can serve your road miles and then spend a quieter retirement stabilizing a home or a microgrid before it finally heads to a recycler, which is how lifetime value becomes more than a buzzword. If the same cells live two lives gracefully, how do we begin to measure sustainability in years rather than headlines? What to treat as confirmed and what to watch. It is tempting to bundle every rumor into this moment, including chatter about hybridized cathodes that blend iron-based and nickel-based approaches to chase higher energy, without abandoning cost advantages. Yet the on-record development is specific and should be treated with care, namely that Tesla's next-generation nickel-based cells leverage doped cathode materials that improve capacity retention and therefore allow a daily limit of 90%, while additional blends and supplier directions remain interesting but separate threads to watch as supply chains localize and chemistries continue to evolve in parallel. For owners and shoppers, the practical takeaway is straightforward, because guidance changes when your particular car ships with the new cells and your manual or app reflects that advice, which means you should follow the current limits for your vehicle until an official prompt makes the higher daily setting explicit. And when that happens, the shift requires nothing more dramatic than moving a slider and enjoying the quiet gift of a larger everyday buffer. If clarity is the difference between confidence and confusion, will a simple line in the app be the moment this story becomes real for you? The competitive ripple that follows. Battery guidance lives in owner communities where practical wisdom travels faster than press releases, which means that once drivers experience nickel packs living happily at 90% with slower apparent aging, rival brands built on similar chemistries will need to match the experience with their own material science moves, or risk the perception that their cars demand more babysitting for the same use case, and suppliers watching this shift will race to harden their own cathodes, so warranties and everyday limits do not become a marketing disadvantage in a category where convenience now speaks louder than raw kilowatt hours. In the short term, you can expect spec sheets and service guidance across the industry to begin talking less about strict daily caps and more about usable energy windows, because once a new norm appears, it is difficult to sell yesterday's rules. And the most interesting outcome may be felt not in top-end flagship models, but in bread-and-butter trims, where a simple increase in daily headroom quietly improves satisfaction scores and reduces support calls without a single change to exterior styling. If expectations shift across showrooms, who wants to be the last to explain why their car still prefers 80% on a Tuesday? The real world wins you will notice first. The advantages show up in places that do not trend on social media, because commuters who used to plug in every night will find they can skip a session without anxiety. Rideshare drivers will carry a larger daily buffer that covers an extra airport run, and families will leave for the weekend without carving every stop around a charger, while fleets will discover that slightly fewer interruptions and slightly slower aging add up to real money over a year and real confidence at defleet time, when residuals depend on battery health as much as on cosmetic condition. Even the psychology of fast charging changes in small ways, because a stronger cathode at higher state of charge makes a quick lunchtime splash feel less like a guilty habit and more like a normal tool, which does not mean owners should abuse the pack, but does mean the pack is designed to be lived with rather than tiptoed around. And when engineering progress feels like a calmer week rather than a louder keynote, you know the improvement has crossed the line from technology to lifestyle. The bottom line for owners and the industry. Taken together, the clear comments and the cathode work describe a coherent move in which Tesla's nickel-based packs gain the right to live at 90% every day, because their cathodes hold their structure and capacity more stubbornly across the years, and the plain language translation of the technical shift points to improved retention that would explain the confidence behind the new guidance, while voices covering the battery ecosystem have begun to frame this as a milestone that narrows the historic gap between nickel and lithium iron phosphate on owner-friendliness without surrendering the density and power that define long-range and performance trims. It is wise to remember that production timing, model eligibility, and software guidance determine when any individual owner benefits. Yet, if the real world mirrors the promise and the on-camera message, daily life with a nickel-based Tesla becomes simpler and more generous, and that kind of quiet revolution tends to spread because it is felt by ordinary drivers on ordinary days, which is exactly where industry leadership either gains ground or loses it. So, if your next Tesla greets you with a higher everyday limit and a pack that ages more gracefully, how will you spend the extra confidence that shows up every morning without asking anything in return? Thermal mastery and the brain behind the pack. To understand why a chemistry change lands so cleanly in real life, you have to consider the other half of the equation, which is the thermal system and the battery management brain that interprets the pack's health and decides how hard to push and how gently to recover, because a toughened cathode without smart temperature control would still pay a penalty, and a beautiful cooling loop without a durable lattice would still face the same calendar losses. And what ties the two together is the way the management system watches thousands of data points, estimates internal resistance and lithium plating risk, and shapes charge curves so the driver experiences speed when it matters and caution when it counts. A higher daily state of charge creates a different thermal profile, since cells near the top of the gauge carry higher voltage and sit closer to stress thresholds, and the only way to make that comfortable is to keep temperatures in the window where side reactions slow down and where the protective interfaces on the anode remain stable, rather than thickening into inefficiency, which is why the combination of a stronger cathode and a more assertive thermal plan reads like a choreography rather than a single trick, and the result is not just a new number on the app, but a lived sense that charging feels consistent from winter to summer and from short hops to long hauls. If the pack behaves like a seasoned athlete with a smart coach and a perfect ice bath, do you feel safer leaning on it in the moments that matter most? Charging curves, taper behavior, and everyday speed. Owners do not think in equations, they think in minutes, and minutes are governed by how quickly a car takes power at different points on the gauge, which is why an improved nickel pack that tolerates more time near the top allows the curve to stay generous a little longer before taper, giving you a few more practical miles in the same cafe stop and smoothing the moment when impatience normally sets in. And because the battery management system can trust the chemistry a bit more, it can deliver that speed with less fear that the long-term cost will show up months later in a quiet loss of capacity. In daily life, that translates to subtle freedoms. Because you can leave home a little later and still arrive with comfortable buffer, you can top up for a few minutes and avoid the habit of pushing the gauge down to 20% before you consider plugging in. And you can plan school runs and gym detours without juggling a mental map of what the car prefers, since the car now prefers what you want most of the time. And while this will never override the laws of physics, it narrows the uncomfortable gap between laboratory promise and driveway reality. If the difference between a stressful day and a smooth one is 10 minutes reclaimed from a charger, how often does that small gift end up changing your plans for the better? Ownership, economics, warranties, and residual value. Batteries are the beating heart of electric vehicles, and they are also the anchor of residual value, which means any improvement in capacity retention, especially at higher daily limits, ripples through the math that lenders, fleets, and private sellers use when predicting what a car will be worth in 3, 5, or 8 years. And as depreciation curves align more closely with conventional vehicles while keeping the benefits of lower running costs, more buyers can justify the jump because the exit door looks less uncertain and the warranty conversations feel anchored in more than optimism. For fleets that work vehicles hard across long days and high annual mileage, a chemistry that holds its nerve after years of 90% living changes utilization models because cars stay on the road with fewer off-cycle battery checks and hold their rate card deeper into life, while fleet managers can point to healthier state of health figures when negotiating wholesale or certified resale channels. And on the private side, owners who plan to keep their cars a decade can do so without anxiety that an invisible timer is running down toward an expensive day. If a stronger cathode lets the numbers make more sense for both head and heart, how many buyers on the fence discover they were just waiting for this kind of confidence all along? The road ahead and the questions that keep us curious. Every new chemistry invites fresh questions, and these nickel-based packs are no exception, since owners will want to see how they handle deep winter, summer heat, and back-to-back fast charges on long trips, whether the battery management system relaxes limits as real-world data rolls in, and how quickly the approach spreads across models and factories. And the only honest answer is that the next seasons of driving will write the verdict as miles accumulate and patterns emerge. What already feels clear is that daily life just got easier for anyone who wanted the legs of a high-energy pack without the old rules, because the car now meets the owner where life happens instead of demanding a routine that belonged to an earlier era. And that is how tech becomes habit. quietly and without a spotlight, by giving you more freedom with fewer worries. If the future of electric ownership is calm confidence rather than constant calculation, is this the moment we look back on and say, batteries finally became as easy as fuel, only smarter, cleaner, and quieter? If this helped, hit like and subscribe, then turn on notifications so you catch the next battery breakdown. Tell us in the comments what daily charge limit you will use and whether this makes you lean nickel or LFP for your next car.